Okay, so बच्चों today we are moving towards some questions of energetics, right? और energetics का बहुत important point जो है आपके पास वो है enthalpy change of the reactions, right? We need to find out enthalpy change of reactions, right? Enthalpy change of reaction. Whenever it is written like this, that means you are going to find out the enthalpy change of the reaction, right? Two questions are very common in exams. The one is enthalpy change of reaction from enthalpy change of formations, right? You need to find out the reactions enthalpy by the formation energies, right? And what is formation? Formation is when any compound is going to form, right? The energy release when 1 mole of any compound form under standard conditions by their constituents, right? And the second very common questions is about the enthalpy change of reaction that you need to find out through enthalpy change of combustion. And enthalpy change of combustion means when 1 mole of any substance is going to be combusted in the presence of excess oxygen under standard conditions. These definitions are very important for exam questions. You need to remember the definition as well, right? It can be asked for 2 or 3 marks, right? So formation is when 1 mole of any substance will be formed from its constituents under standard conditions. This can be asked in exam. And enthalpy change of combustion की definition क्या होगी बच्चों? When 1 mole of any substance combusted in the presence of excess oxygen, right, under standard conditions. So you need to write the definition, the energy difference, yeah, enthalpy change when 1 mole of any substance combusted in the presence of excess oxygen under standard conditions. This definition can be asked for 3 marks as well, right? So you need to remember the definition as well, right? I will share some definitions with you on WhatsApp, inshallah, after the class. So you need to learn all definitions. They can be asked to give you marks, right? Okay, now we are going to start the first one, enthalpy change of reaction from the formation energies, right? In the question, you will find the information like this. They gave us some enthalpy change of formation like this. For example, there is a reaction like carbon monoxide reacting with nitrogen monoxide, forming carbon dioxide and nitrogen gas, right? For example, this is one of the reaction, right? And the examiner is asking to find out the enthalpy change of this reaction, right? And they gave you some formation energies, like they gave you when carbon monoxide form. When carbon monoxide form, the enthalpy change of formation of carbon monoxide is, for example, it is, I'm just assuming few values over here, not they are exactly the same values. For example, it is 800 kilojoules per mole. Whenever carbon monoxide form, for example, 800 kilojoules per mole energy release. It means when 1 mole of carbon monoxide form, this energy will be going to given out because the sign is negative, right? So they gave us the second one as well. For example, nitrogen monoxide, they are saying that when this molecule is formed, for example, the energy release will be 600 kilojoules per mole, right? This is just the assumed values, right? And then they gave us also about carbon dioxide. For example, when carbon dioxide form, for example, the energy release will be 1000 kilojoules per mole, right? Now, what about nitrogen? But nitrogen is itself element, right? So elements are always there. So they are not going to be formed. So there is no energy release and absorbed when any molecule will be there or when element will be there, right? So nitrogen is actually existing in the nature in the N2 form. So it is not going to be produced. It is there in the environment. Whenever we talk about the air, so nitrogen is present over there in the form of N2. तो ये produce नहीं होगा, ये इसी form में मिलता है हमें ना, तो इसकी कोई energy वगैरह नहीं होगी. It will be zero, right? इसी तरह अगर आपके पास आयरन लिखा हुआ है, आपके पास सोडियम लिखा हुआ, जो भी एलिमेंटल फॉर्म में आपके पास चीज लिखी हुई होगी ना, उसकी एंथैल्पी चेंज ऑफ फॉर्मेशन नहीं होगी. ऑक्सीजन लिखा हुआ है O2, हाइड्रोजन लिखा हुआ है H2, so they all are zero, right? So first of all, you need to make a cycle for this to make this question easier, right? So what is the cycle? Actually, they are enthalpy change of formations. So formations का मतलब है कि these compounds are going to be formed, right? And definitely these compounds are going to be formed by their कॉन्स्टिट्यूएंट्स, यानी कि इसके अंदर जो जो चीजें हैं उन्हीं से बन रहे होंगे ना ये। तो कार्बन मोनोऑक्साइड के अंदर क्या है, कार्बन है और ऑक्सीजन है, राइट। सो बाय दीज टू एलिमेंट्स this carbon monoxide is going to be formed, right? Then if you want to form nitrogen monoxide, so definitely for this you want nitrogen gas and oxygen gas. When these two gases combine together, they will form what? Nitrogen monoxide. And when carbon and oxygen combine together, so they will form carbon dioxide and nitrogen to nitrogen, right? So we always form compounds through their reactants or their constituents, right? So these are the arrow you need to remember. Whenever the substance is going to be formed, you need to show the head towards the compound, क्योंकि वो formed हो रहा है, तो form हो रहा है तो वो head के पास आएगा, ठीक है ना? So we know the values. Carbon monoxide form होगी तो 800 डिग्री सेंटीग्रेड, और नाइट्रोजन मोनोऑक्साइड फॉर्म होगी तो 600 डिग्री kilojoules per mole, right? And जब कार्बन डाइऑक्साइड फॉर्म होगी तो 1000 kilojoules per mole, right? And नाइट्रोजन जब फॉर्म होगी it should be 0 because it is in the elemental form, right? And this is to be identified. Now remember one thing, the arrows in the same direction will be added together and they will be equal to the opposite direction arrows, right? You can see over here, this arrow is going to be in the same direction, right? Both of the arrows are in the same direction, and this is also in the same direction, right? So these arrows should be added and this is in the opposite direction and this is also in the opposite direction. So you can write the statement over here like this, that enthalpy change of formation of carbon monoxide plus enthalpy change of formation of nitrogen monoxide plus enthalpy change of reaction that we need to find out is equals to, और बाकी arrows उस तरफ आ रहे हैं, तो enthalpy change of formation of carbon dioxide plus enthalpy change of formation of nitrogen, right? And just put the values and get the answer, right? So it is actually 800, it is minus 600 plus this is need to be find out, right? And this is minus 1000 kilojoules per mole and this is 0, right? So it is minus 1400 plus dash r minus 1000. This negative will go over there to become positive, and the enthalpy change of the reaction of this reaction will be 400 kilojoules per mole. Is that right, Bacho?
Yes, sir.
Yes, Arsalan and Alia. Is that clear to all of you?
Yes, sir.
Okay, this is one of the very common question in the exam. You need to be very conscious about this. You need to focus on this word. If this is formation, so you all need to do according to this pattern that I show on the screen right now, right? And same as it is, if the second part will be asking in the exam, so it will concern with the combustion. So the arrows are completely reversed, right? So second part is you need to find out enthalpy change of reaction from enthalpy changes of combustion, right? So for example, there is a reaction that for example, we have C2H4 reacting with hydrogen and forming C2H6. This is a reaction, for example, right? And they gave us what? Enthalpy changes of combustions. We know that that C2H4 is a hydrocarbon, so it can burn. So this is one of the fuel, right? The enthalpy change of combustion of C2H4, for example, it is negative 400 kilojoules per mole. And we know that hydrogen is also a fuel which can use in a rocket fuel. The enthalpy change of combustion of hydrogen gas is actually, for example, 1000 kilojoules per mole. And for example, enthalpy change of combustion of ethane molecule C2H6, for example, it is minus 750 kilojoules per mole. Now you can see this, these are the combustions given to you. Now, we need to find out enthalpy change of the reaction that they are just giving over here. and they give us a combustion equation. Now the arrows are completely opposite. You can write over here, whenever C2H4 combusted, it will form carbon dioxide and water, right? Whenever hydrogen combusted, it will form what? Only water. And whenever this one is going to be combusted, it is also going to produce carbon dioxide and water. No need to specify the product over here. We just need to know that ये carbon dioxide और water ही बनना है इसमें ना, तो arrow का head कहीं पर भी हो, doesn't matter. आपने सिर्फ और सिर्फ ये cycle बना लेनी है अपनी आसानी के लिए. Now you can see this C2H4 when burned, it will produce 400 kilojoule energy. It will produce 1000. It will produce 750. Right now, just again see the arrows. Right, if you focus on the arrows, so you can see this. This one is going to be in the same direction. Right, so these two are going to be added. Right, and these two arrows are completely opposite in direction, so they will be on the other hand. So you can write over here that enthalpy change of combustion of C2H4 plus enthalpy change of combustion of hydrogen is equals to enthalpy change of the reaction plus enthalpy change of combustion of C2H6. Right, just put the values and get the answer. So the first one is minus 400 plus this is minus 1000, and this is to be identified, and this one is minus 750. Now this is 1400, right, and this is delta HR minus 750. When 750 is coming over here, it is going to be plus, and the answer will be delta HR will be negative 650 kilojoules per mole. Is that right, बच्चों?
चलिए CO2 और H2O कैसे फॉर्म हुआ?
But whenever you are going to combust any organic compound, it is always going to produce the products of the elements with oxygen, right? For example, अगर आपके पास C2H4 है, तो इसके अंदर कौन-कौन से दो elements हैं? कार्बन और हाइड्रोजन. तो डेफिनेटली जब ये कंबस्ट होगा तो एक कार्बन अपना ऑक्सीजन का कंपाउंड बनाएगा, हाइड्रोजन अपना बनाएगा, तो कार्बन डाइऑक्साइड और वाटर भी बनेगा, है ना? हाइड्रोजन जब कंबस्ट होगा तो वो पानी बनाएगा खाली. C2H6 जब कंबस्ट होगा ये भी कार्बन डाइऑक्साइड और वाटर बनाएगा. We write the product names only. There is no need of carbon dioxide and water over here, but still, if you want to make a cycle for your betterment in your question answers, right? So you can do this, and it can be asked in exam as well. Sometimes draw the cycle as well. So it is very important. Otherwise, if you want to use the direct formula, so you can even use the formula as well. The combustion of the reactants is always equal to the enthalpy change of reaction plus the combustion of product. You can use this formula directly as well and put the values and get the answer, right? ठीक है बच्चों? ठीक है अरसलान? Okay, let's see some example questions from the dwarf paper. Okay, so for example, if you want to find out the enthalpy change of reaction, it is a different question. For example, you need to find out a enthalpy change of reaction from bond energies, right? Bond energies are always given to you in data booklet, right? Or if it is not given to you, the data booklet in the upcoming paper, so definitely these values will be given to you in your question. Then this is a question, for example, 4NH3 reacting with 5 oxygen gas molecules and forming 4 nitrogen monoxide plus 6 water molecules. This is the question, and they gave us the bond energies as well. A bond and the energies in kilojoules, right? There's in kilojoule, right? They gave us bond like an H का bond उन्होंने हमें दिया है, which is having 391 energy. Oxygen का bond उन्होंने हमें दिया है, which is having 498 energy. And they gave us nitrogen and oxygen double bond with 587 kilojoule energy, and OH bond with 464 energy, right? Now we need to write this equation in the term of bonds, right? So let's write this. NH3 is like this, right? And we have 4 molecules of NH3. This is like this. And we have 5 oxygen molecules, so this is like this. And nitrogen monoxide, they gave us nitrogen monoxide is actually nitrogen double bond oxygen. And we have 4 bond of this with 6 water molecules. And we know that water molecule is actually a bond of like this, right? So we need to solve this question in this way. You need to remember this. This is actually the bond breaking. So this is endothermic reaction. ये bond टूटेंगे. So these bond will be formed. This is exothermic. So the value over here will be positive and this will be negative, right? And then you just take a difference of these two values, right? So 4, and we have in each molecule we have N2H bonds, 3 N2H bonds in a single ammonia. So it is 4 into 3 NH bonds, and then these are actually 5 oxygen to oxygen bonds, right? So 12, and each NH bond having 391 energy, so it is 12 into 391 plus 5 into 498. This will be the endothermic part. So what will be the answer of the summation of these values will be positive, right? And now on the product side, if you focus over here, so it is 4 into N double bond oxygen 587 and a single, we need to write like this, and 2 O bonds. And in each water molecule we have 2 O2H bonds, right? It is 6 into 2 O2H bonds. So that means 4 into 4 into 587 plus 12 into 464. So whatever with the value, it will be negative in sign, right? Because this is exothermic reaction, bond formation is exothermic, right? So let's calculate the values. It is 12 into 391. It is 4692 plus 5 into 498. It is 2490, right? And over here, if you solve this one, 4 into 587, it is 2348 plus 12 into 464. So it is 5568, right? Now 4692 plus 2490 will give you plus 7182 minus the next value is 2348 plus 5568. It is giving us what? 7916. If we subtract these values, so it will give us 734 negative. This is the energy change of this reaction. This is the energy change of this reaction. The overall energy change of this reaction is 734 kilojoules. This is the overall energy of the reaction. This is energy of the reaction, right? Now, the problem is this. If you want to find out the enthalpy change of the reaction, so this is fine. This is the enthalpy change of the reaction, kilojoules per mole. But if you want to find out the energy enthalpy change of the reaction when 1 mole of ammonia is reacted, if you want to find out when 1 mole of ammonia is reacted, so the actual equation of 1 mole is NH3, and this will be 5 over 4 O2. It will be forming 1 NO plus 6 over 4 H2O. This is the equation for 1 mole of ammonia, when 1 mole of ammonia is going to react. If you want to find out the enthalpy change of the reaction when 1 mole of ammonia is used, then the overall reaction will be divided by 4. So this is the enthalpy change of the reaction. If you want to find out like this, so it will be divided by 4. It is not necessary right now, but if you want to do this, you can find out the energy change of the reaction for 1 mole as well. All right, so this is what you need to understand. What is the reaction? The overall reaction is what? The overall reaction is exothermic. Why? Because you can write that energy release by bond making. Over here, the energy released by bond making is greater than energy absorbed for bond breaking. That is why the overall reaction is exothermic. Therefore, the overall reaction is exothermic. When in this reaction, and bond breaking and bond making occurring at the same time, but overall the overall reaction is exothermic because the energy released by bond making is greater. So that is why the overall reaction is exothermic. Is that right, every one of you? Yes, is that right, Bacho?
Yes, sir.